Good morning to one and all present here. In this video lecture series, we are going to discuss about data formats for additive manufacturing in the subject 3D printing. What is 3D printing? 3D printing, it is also known as an additive manufacturing process, whereas it revolutionizes the way products are designed and manufactured. However, before a part can be printed, the digital design must be converted into a format that the printer can understand. In this video, we will discuss about what are all the different data formats in additive manufacturing, why are they important, and also we will discuss about the types of data formats which is used in 3D printing, advantages and limitations of each format, and emerging data formats for Industry 4.0 applications, etc. Let's begin. What is the data format in the additive manufacturing? A data format is a method of storing and transferring the geometric and manufacturing information of a 3D model which is produced from the CAD software to a 3D printer. The workflow generally follows. First, we need to design the CAD model with the help of either an AutoCAD or ProE or any one type of 3D software, and then we need to convert the data conversion into the following format, and then slicing software. With the help of slicing software, we need to slice the particular 3D product, and then the G codes can be generated and it is incorporated in the 3D printer. Once the machine runs, we can print the material which is designed in the 3D printer. The data format acts as a bridge between the design stage and the manufacturing stage. An ideal data format should contain accurately represent its geometry, preserve dimensional information, support material information, reduce the file size, and minimize its error. Now we are going to discuss about the different data formats which is used in the additive manufacturing. The most commonly used data formats, some of them are STL format, AMF format, 3M format, step format, IGS, OBJ, G code format, etc. Now we are going to discuss it one by one. What is an STL format? STL stands for Standard Tessellation Language or Stereolithography. It is developed by 3D Systems in the year 1987 for stereolithography machines. The major working principle behind it is the surface of a 3D object is represented using thousands of small triangles, as it is indicated in the PPT, Industry Standard Triangular Mesh format. The more triangles used, the smoother the surface appears. The major features are it represents only the geometry, and also it contains triangular mesh information supported by all types of 3D printers. Advantages are it is simple and widely accepted, easy to generate, compatible with most slicing software. The major limitations of this type of format is no color information can be identified, no material information, large file size for complex geometries cannot be generated, etc. Next, we are going to discuss about the OBJ format. What is an OBJ? OBJ is a file format which is developed by Wavefront Technologies. It stores geometry, texture, color, surface information. Whereas in the case of STL format, it only stores the geometry of the particular product. Whereas in case of OBJ, it stores. Next, we are going to discuss about an AMF format. That means Additive Manufacturing File Format. What is? It was developed by ASTM International to overcome the STL limitations. Information stored. AMF can store its geometry, color, texture, its material properties, lattice structures, multiple objects, etc. The major advantages is it has higher accuracy, smaller file size than STL file format, and also it supports multi-material printing. It supports curved surfaces efficiently. Next, we will going to discuss about the next format, 3MF format. It stands for 3D Manufacturing Format. It is developed by 3MF Consortium, which includes major companies such as Microsoft, HP, Autodesk, Dassault Systems, etc. 3MF stores geometry, color, materials, build orientation, manufacturing settings, metadata, etc. The major advantages are compact file size, higher accuracy, it supports advanced manufacturing data, eliminates the common STL errors, and also it is majorly used in Industry 4.0 environments. The major applications of this format is it is majorly used in metal additive manufacturing process, multi